Hi all, I hope you all are doing well. Today we are going to discuss about types of semiconductor. Semiconductor is the device whose conductivity lies between conductor and insulator. It has two types, extrinsic semiconductor and intrinsic semiconductor. Intrinsic semiconductor conductor it is extremely pure form of semiconductor and it has some property that electron and holes are solely created by thermal excitation, number of free electron equal to the number of holes, and the conduction capacity is small at room temperature. This is the properties of intrinsic semiconductor. You can see in crystal lattice structure of silicon atom. Here the four electron are making covalent bonding with another four electron of silicon atom. So there is no free electron. In order to increase the conduction capacity of intrinsic semiconductor, it is better to add some impurities. The process of adding impurity is nothing but doping. So the dope intrinsic semiconductor conductor it is called as extrinsic semiconductor. Yeah. In this figure, you can see when pentavalent impurity added to the silicon crystal, the four valence electron are making covalent bonding with the four valence electron of the silicon atom and one free electron you can see. So it is a donor atom. So intrinsic semiconductor is a pure semiconductor in which no impurities are added. Is called as intrinsic semiconductor. Pure germanium and silicon in their natural state are intrinsic semiconductor. Now let's move to the extrinsic semiconductor. An impure semiconductor which is formed by doping a pure semiconductor is called extrinsic semiconductor. There are two types of extrinsic semiconductor depending on the types of impurity added. There are n-type extrinsic semiconductor and p-type extrinsic semiconductor. In n-type extrinsic semiconductor you can see small amount of pentavalent impurity is added to a pure semiconductor. Result a n-type extrinsic semiconductor. The added impurity has 5 valence electron. In this figure you can see arsenic atom is added to the germanium atom. So 4 electron of arsenic attached with 4 electron of germanium. So 4 valence electron created bond, that is covalent bond. This is the covalent bond between them, and one free electron of arsenic remain as a free electron. It helps to flow current. All electrons free help in conduction process. Yeah. So the pentavalent atom is called as a donor atom because it donate electron to the conduction band of pure semiconductor atom. Pentavalent has five electron in the outermost orbit. The example is bismuth, antimony, arsenic, phosphorus. In n-type semiconductor, as the conduction takes place through the electron are a majority carrier and holes are minority carrier. As there is no addition of positive or negative charges, the electron are electrically neutral. When an electric field is applied to an n-type semiconductor to which pentavalent impurity is added, the free electron travel through the positive electrode. This is called as a negative or n-type conductivity. Okay, so let's move to this p-type semiconductor. A small amount of impurity is added to the pure semiconductor result in p-type extrinsic semiconductor. The added impurity has 3 valence electrons. If boron atom is added to the germanium atom, a 3 of valence electron get attached with the germanium atom to form 3 covalent bond. In this figure you can see there is a 1 electron in germanium remain without forming any bond. There is no electron in boron remain to form a covalent bond. The space is created, that is hole. The trivalent impurity has 3 valence electron in outermost orbit. So the trivalent atom is called as acceptor atom because it accepts one atom, one electron from the semiconductor atom, and p-type extrinsic semiconductor. As the conduction takes place through holes, holes are majority carrier while the electron are minority carrier. The impurity added here provide holes with which are called an acceptors because they accepts electron from the germanium atom. As the number of moving holes equal to the number of acceptor, and p-type semiconductor remain electrically neutral. When electric field is applied to p-type semiconductor to which trivalent impurity is added, the holes are travel toward negative electrode, but with a slow place through the electrons. These add as a p-type conductivity. This is the type of conductivity which is called as p-type, and this p-type conductivity valence electron move from one covalent bond to another. That's all about p-type and n-type semiconductor. Thank you.